Okay, so here we are, we're working through 2016 paper 1, question 4. I have it off freeze now, and it's a calculus question. Calculus and functions come together, so you need to know that you need to know both topics really. So let's just look at this before we go anywhere with it and just pick out some key words. So the function, so there's our clue, there's our function. The function f of x goes to, so here's the actual function here, that's the key bit, okay, and don't forget with functions that could also be y equals, and it could also be written f bracket x equals. So those are 3 different ways.
Is that arrow?
Yeah.
Is that equals? Basically?
Yeah, basically it's equals as well. It's basically saying x goes to x cubed plus x squared minus 2x plus 7. But exactly, yeah, it's equals. Very good. Okay, so that's our function. This bit here is just jargon to tell you that any number could be an answer. Okay, so R is real numbers. So basically any question where you draw a graph is going to have x an element of R, because you have to be able to draw a line that joins up the points. So it has to include any possible number. So x an element of R means any real number. Find the I'm not going to do it yet, I'm just going to read it through. Find the coordinates of the point at which the graph, so the coordinates, that's important, of the point at which the graph of f cuts the y-axis. That's very important. Verify using algebra, so not using a graph but using algebra, that the point 1, 7 is on the graph of f. So there's the point, we've got to show that it's on the graph of f. Now f was x cubed plus x squared minus 2x plus 7. So I'm going to put that in there. Okay, check that it's on the graph, that's right. And then that's that bit, we'll do that in a minute. Verify just means show it to be true. So prove, that's what verify means. And then the next one says find f dash x, so that's a key thing there. Remember f dash x is the same as saying dy dx. So whenever you see f dash x, you're thinking dy dx, and that means differentiate. Hence, that's important, hence means I've got to use what I just did. Hence find the slope of the tangent to the graph. Now, once you see slope and it's a differentiation question, you don't think rise over run. What you think of slope when you see, so what you think of when you see the word slope, you think dy dx. Okay, so I think I mentioned to you before, I normally, if I haven't mentioned it already, I normally start mentioning it around now, that if you want to get a bit of paper at home and write down slope equals dy dx on a bit of paper and stick it somewhere in your room so that you see it lots, that's really important because that comes up a lot. Okay, when x equals 1. And then hence find the equation of the tangent. So this is the harder bit. Hence find the equation of the tangent to the graph of f. So the equation of the tangent to the graph of f at the point 1, 7. So that's the hard bit. That's going to be maybe a 5 marks at the end. It might even be a 7 or 8. But we should be able to get a good 15 marks here anyway, if we can get this bit done. And 15 marks out of 25 would be 60%. Which on a calculus question, that'd be good. If you can get 60% in a calculus question in the mocks, that's great. Because calculus is tough in the mocks. Okay, so let's see how this works. So this is my function, x cubed plus x squared minus 2x plus 7. So that's my function, x cubed plus x squared minus 2x plus 7. And if you remember, it's one of these wobbly ones. Yeah. So it's going to be either something like this, yeah, or it's going to be something like this, okay, if it's got an x cubed. Now, find the coordinates of the point at which the graph of f cuts the y-axis. So what they want you to remember is that anything that cuts the y-axis, so that's there, and that's there, on the y-axis, the x value is 0. So the y-axis has an x value of 0. Any point on the y-axis is 0 something. So if they want us to find the coordinates of this point, coordinates, so that's like this, of this point at which the graph cuts the y-axis, what they want us to know is that the x value is 0, and we're just trying to find the y. Now, we just said a minute ago that this here f dot 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 x with an arrow is the same as f of x, and it's the same as y. So this is saying y equals x cubed plus x squared minus 2x plus 7. But we now know, because it cuts the y-axis, and that means x equals 0, I'm going to put 0 in wherever there's an x. And whatever I get out is going to be the y value that goes with x equals 0. Okay, cuts the y-axis meant x equals 0. If x equals 0 means I put 0 in instead of x, and I work it through. So that's 0 plus 0 minus 0 plus 7. So y is equal to 7.
Why do you do 0 though? Sorry.
Why do I do 0? Good question. Okay, so I do 0 because I'm putting something in for x. Why did I choose 0 for x? I chose 0 for x because it tells me it's where it cuts the y-axis. I'm looking for this point here, or maybe it's this point here, but it's where the curve cuts the y-axis.
Right, yeah.
Is that all right? And anywhere on the y-axis, x is 0. Right. Is that okay? So y equals 7. When x equals 0, y equals 7. So the coordinates of the point where it cuts the y-axis are 0, 7. That's a really common type of question, not just in calculus, but in graphs and in coordinate geometry, to know that where something cuts the y-axis, x equals 0, and where it cuts the x-axis, y equals 0. Okay? The next thing says verify, so prove using algebra. Well, this is algebra. What I've just done here is algebra. Okay? That the point A, 1, 7. So they've called this point A, and they've told me it's 1, 7, and they know that it's on the graph. So if I was to plot this graph of this function, there would be a point 1, 7 on it. Now, let's look at 1, 7. 1, 7, that's my x number, and that's my y number. Now, let's look at my function again, because that's the graph of f. F is my function. My function is y is equal to x cubed plus x squared minus 2x plus 7. Now, look, I've got an x here and I've got a y here. So how about if wherever I have a y, I put 7, and wherever I have an x, I put 1, and see whether that works out to be true. Because if this point 1, 7 is on this function, then if I put it into the function, it should work. That's the definition of what makes it on the curve at all, or on the function at all, is the point works in the function. So here I've got 7 is equal to 1 plus 1 minus 2 plus 7. That's just 1 cubed is 1, 1 squared is 1, 2 by 1 is 2, and 7. So 7 is equal to, well, 1 and 1 is 2, and 2 minus 2 is 0, plus 7 is 7. Yes, that's true. So I've shown that if I put 1 in for x, I get a y value equal to 7. In other words, the point 1, 7 is on that curve, is on that function. Anybody want to ask me about that bit? And again, that's really common. So if you can get that into your head, that will be really good. Is that okay? Okay. Part C says find f dash x, the derivative of f of x. So this is my function, which is this. And they want me to find f dash x, which, as we said a moment ago, f dash x is the same as dy dx. It means differentiate. So derivative, dy dx, differentiate, and f dash x all mean the same thing. They all mean differentiate. So let's find f dash x. Well, I'm going to write down what f of x is. Now, I have to say, I don't think you'll be penalized if you were to write down y equals. But I'm just going to stick with this, the notation they're using. So that's my function. F dash x is the same as dy dx. I think you'll be fine if you write down dy dx rather than f dash x. I don't think they will penalise you. I think you get full marks if you differentiate correctly. But remember, you have to write that down. Do you remember when we were doing that topic, I said to you, you have to write down dy dx or f dash x or you lose marks. So you have to write that bit down in one of those forms. Okay? So x cubed, if you remember your differentiation, x cubed, when I differentiate it, the power comes down in front and I reduce the power by 1. So x cubed becomes 3x squared. X squared becomes 2x to the power of 1. We just say 2x. Minus 2x, remember if it's just so many x's, we just keep the number, the coefficient, we keep the number in front. So minus 2, and the 7 goes to 0. So it becomes 0, which we get rid of. So f dash x is equal to 3x squared plus 2x minus 2. So I'll just go through that again, because we haven't done differentiation for a while. What happens is when we differentiate, we bring the power down in front and then reduce the power by 1. So x cubed becomes 3x squared, x squared becomes 2x, minus 2x. If it's just the x, what happens is that power is a power of 1 and it reduces to 0. And what happens is it just becomes minus 2. So if it's just x by itself, we just keep the number in front of it. And if it's a constant, if it's a number without x, we lose that completely. Okay? Any questions on that bit? Okay, so now here's the bit that's a bit harder. Hence find the slope of the tangent to the graph of f when x equals 1. We said a minute ago that dy dx and f dash x are the same as slope. What we could also say that they're the same as the slope of the tangent to the curve. So when we say slope, we're saying slope of the tangent to the curve. Now, what they're saying to us here is hence, so use what you've just done, which is this, find the slope of the tangent to the curve. So find the slope of the tangent to the curve when x equals 1. The slope is the same as saying dy dx. So they're asking me to find dy dx, but I just did that. So what are they asking me to do? They're asking me to find dy dx when x equals 1. Or find f dash x when x equals 1. And I got that 1 from there, look. That's where I'm getting x equals 1 from. So what I'm going to do is I'm going to put in slope at x equals 1 is going to be, I'm going to put 1 into here, into my dy dx, into my f dash x. So 3 by 1 squared plus 2 by 1 minus 2. So that is 3 by 1, which is 3, 2 by 1, which is 2, minus 2, so that is 3. So the slope of my curve is asking me for the dy dx of my curve. The first bit I did was the general slope for any point on the curve. The second bit I did is finding the slope at a particular point, which is x equals 1. That's really hard for you guys, I know.
Wait, why don't you times
Here
Yeah.
or
Yeah.
there, because 1 squared is 1.
Yeah, but it's 3 times 1 is 3, and you're not going to do
Okay, very good. Yeah, okay, so 3 by 1 squared means square the 1 and multiply it by 3. What you're asking me would be this.
Yeah. Okay.
So this, I just do the number in the bracket.
Okay.
I square it, and that's what I multiply by 3. This 3 isn't squared. What this would be 3 squared, 1 squared.
Okay.
But the 3 isn't squared.
Okay.
Okay, I'm going to scribble that out just so that Does it confuse? So that this is I think this is really hard, this bit here. The maths of it, like doing it's not hard. Like if I told you differentiate and then sub x equals 1 into what you've differentiated, you'd go, oh yeah, I know how to do that. But to know that what they mean by the slope of the tangent to the graph at x equals 1 is really hard. So by June, we'll find that much easier. But for now, I do understand that's challenging. Okay? Hi.
For dy dx, do you
Yeah.
multiply or square?
Sorry, which part of it?
Well, like, say it was cube.
Yeah.
So 1 cube.
Yeah.
Or sorry, 2 cube. would be
Yeah.
6 or would it be
So if I was differentiating, let's go down to the bottom here. Actually, use this bit of paper here. So what you're saying to me is if I had 2x cubed, is that what you mean?
Yeah.
And I was differentiating that?
Yeah.
Yeah?
Yeah.
What do you think it would be?
I don't know.
So I multiply the 3 by the 2,
Yeah.
which would be 6x squared.
Okay.
Is that, but I'm not sure that's what you're asking me.
No, I think it was
If you remember it, ask me.
Yeah.
Okay.
Sorry, Phil was distracted.
I know, it's shocking. Okay, so does anyone want to ask me anything about that? I think I've explained it. If you're not sure, you can go back and watch it again and see. Okay, now, this is the really hard bit. Okay, so what they're saying here, hence find the equation of the tangent. Now let's think, equation of a tangent. Let's imagine we've got a curve like that or like that. A tangent to the curve is a line that cuts the curve at one point. Those are all tangents to the curve. Okay? Now, what are they? They're all lines. Yeah? So a tangent to the curve is a line. And what they're asking us for is the equation of the tangent. So they're asking us for the equation of the line. That will be the equation of the tangent. Okay, so let's unpack that. Let's change this now. Find the equation of a line. So, equation of a line is this equation, the one from coordinate geometry. Okay, let's just keep that in mind for a minute. We'll just write that there. Now, find the equation of the tangent to the graph of f. So to this function we've been talking about at the point A, which is 1, 7. Okay. So earlier on they had us showing that 1, 7 was on the curve, but that's not much good to us now. So that's what they've told us to do. And we've just talked here about how that means find the equation of a line. Now looking at this, if you remember back to your coordinate geometry, which you possibly won't, you'll remember this here stays as y. This here stays as x. This and this change. And they're the point x1, y1. Okay, now there's a point, 1, 7. And there's a point. That point there is going to be my x1, y1. Okay? Now, what else is in this formula? The other thing in this formula is m, which is a slope. They need me to find a slope, but I've just found a slope. The slope was 3. Now, if the worst came to the worst, and you managed to find the equation of the line using the point 1, 7 and the slope 3, you'd get nearly all the marks. And I think you'd be doing really well. Okay? But unfortunately, it's slightly different to that. Because the tangent to a curve has a perpendicular slope. Okay? Actually, no, let's leave that. It's not. We'll ignore that because actually that's more to do with the circle. You can take it that the slope is actually the slope we just found. It's not as nasty as I just said. So the slope we just found in here I was thinking of the tangent to a circle, which is different, which is a perpendicular to the radius. So I was getting myself mixed up there. Okay, the slope that we're going to use is the slope we just found. So the slope we just found here a minute ago is 3. We just found that out. And that's our m. And the point is x1, y1. And we just found that out. That is, or we were told that that's 1, 7. We have a slope. We have a point. We're going to use our formula. Y minus y1 is equal to m by x minus x1. Now I'm going to work that through in a moment, but let's just see how could we maximize our points here. So I look at that and I'm overwhelmed because I was doing calculus and then I was doing some algebra and then I was finding a slope, and now they're asking me to do the equation of a line, and I'm thinking, hang on, this isn't a coordinate geometry question, my head is wrecked. So let's try and maximize our points. By writing down slope equals 3, you should get some points. And by writing down the point 1, 7, you might get additional points, you might not. But by writing down the equation of the line, if you remember, if you go, oh yeah, that means it's the equation of a line, and subbing in correctly, okay, x1, y1, you're going to get nearly full marks. Y minus y1, sorry, that's 7. Y minus 7 is equal to 3 by x minus 1. So you've almost got full marks here. So really, for those, that kind of applies both to those of you that want to get your O1, but an O2 that are struggling a bit with calculus, and those of you that want to make sure you pass. You're trying to get anything you can do to make sure you pick up some points. So anything there that you do is going to be beneficial. It's going to get you some points. So now I'm just going to work it through. Y minus 7 is equal to 3x minus 3. 3 by x and 3 by minus 1. And then the easiest way, they haven't told me what form to give my equation in. That's the easiest one to answer in. Y equals, because all I had to do was move that 7 over. I'd probably only lose a mark anyway if I didn't get to that stage. If I left it like that, I'd probably get nearly all the marks. So this is the equation of the tangent, which is a line, to the curve at 1, 7. Okay, I'm going to just stop this.